Student, our next rearrangement is the Bayer-Villiger rearrangement, in which ketone or aldehyde when react with acid, it will be undergoes the oxidation reaction, and this oxidation reaction is known as the Bayer-Villiger rearrangement. Here, alkyl group will migrate from carbon to electron deficient oxygen, and migration is the 1-2 migration. So therefore, this is the example of 1-2 migration reaction from carbon to electron deficient oxygen. This reaction is very important to convert the ketone to the carboxylic ester, because conversion of ketone to the carboxylic ester is important reaction in the organic synthesis. When we use here the aldehyde and aldehyde is converted into acid, this is not important because there are number of reactions reported for the conversion of aldehyde to the acids. When we oxidize aldehyde by the various oxidizing agent, it will be give us the acids. But this is important to conversion of ketone to esters, because this conversion is not commonly found. So here we have to attention conversion of ketone to the ester by Bayer-Villiger rearrangement. So I write here the conversion. Conversion is ketone to ester and aldehyde to acids. So here we can write ketone R C double bond O R dash when react with firstly mineral acid in the presence of per acid. So I write here the structure of per acid, C double bond O O H. Then it gives R C double bond O R dash, that is the ester. And when aldehyde react with mineral acid first and then per acid, it will give us the carboxylic acid. This is the OH. So this is the conversion in Bayer-Villiger reaction. Ketone will react with mineral acid and per acid. Then this ester and aldehyde give us the carboxylic acid. Let us discuss here the mechanism. See, this is R C double bond O R dash ketone. When firstly react with mineral acid gives H plus ion, and this lone pair of oxygen will take this H plus ion. So we got here the protonated ketone. This is the protonated ketone here. This is R dash, and this oxygen now having positive charge. So this is R C double bond O. This is O here, and this is the OH. So this is nothing but the per acid. This is nothing but the per acid, and per acid now attached to this carbonyl will be attached to this carbonyl carbon. This bond get open here, and got here the new structure. This is R, this is OH here, this is R dash here, and this is O. So after deprotonation to this oxygen, we got this oxygen. This is the O, this is C double bond O, and this is R here. This is R here. Now we can write this hydrogen in such a way. We can write this hydrogen in such a way. So very simple simple way, this reaction is proceed in a presence of mineral acid. Hence, this lone pair again can take the H plus ion from the mineral acid and we got the new structure. This is R, this is OH, this is R dash, this is O, this is again O, this is C double bond O, and this is H, this is now oxygen positive charge, and this is the R. The conjugate base that present in the reaction will take this hydrogen, this bond will be shift here and makes here the double bond oxygen, and this whole R group will shift to this oxygen, this bond shift here, and this bond get open and neutralize the positive charge. So we got here C, this is R, this is C, this is double bond O, this carbon now attached to this oxygen, and this now oxygen now attached to this R dash. So this is the ester found here from this ketone. So from Bayer-Villiger reaction we can convert this ketone into this ester, and the per acid will convert into the acid. See, this is the C double bond O. So this is C double bond O, which per acid will convert into this. So our target is this ester. This is the mechanism that we can use here and convert the ketone into the ester. Let us see here the one example. See, when this cyclohexane react with firstly mineral acid, the lone pair of this oxygen will take this proton, and we got here the protonated ketone. So this is the H plus ion. This is the H plus ion. Now the per acid, I write here this per acid in such a way. This is the OH, this is C double bond O, and this is the CH, per acetic acid that we have used here. This lone pair will be attached here, and this positive charge will be neutralized, and we got here this. See, this is the OH here, and this is the oxygen here, and by minus protonation we can extract this hydrogen by conjugating base. This is oxygen, this is C double bond O, this is CH3 here. Now, as we use here the mineral acid, this lone pair of oxygen can take this proton, and here is the protonation will be formed here. So this is O, this is H, this is O here, this is O here, this is oxygen, this is C double bond O, H is oxygen, this is the C. Now when conjugate base will take this proton, this bond will be shifted here. This bond will be shifted here. Now this carbon-carbon bond will be break, and this bond will be shifted to this oxygen. This bond will be shifted here, and this bond will be open here and neutralize the positive charge. So see, in this way, this 6-membered ring now expand to the 7-membered ring. 6-membered ring now expand to the 7-membered ring, and the 7-membered ring can be written in this way. See, this is the first carbon atom. See, this is the first carbon atom. It will be the second. It will be the second. Oxygen will be the second here. So here will be the oxygen. 1, 2, 3, 4, 5, 6, and 7. 2, 3, 4, 5, 6, and 7. Plus here will be the formation of acetic acid, CH3, C double bond O and OH. So in this way, here is the formation of lactone. As we say that ketone is converted into the esters. So, by the same way, cyclic ketone will be converted into the lactone. Cyclic ketone will be converted into the lactone. This is the example of Bayer-Villiger rearrangement.